Welcome to my YouTube channel. Today we're going to look at the graph of momentum um, of two colliding objects. Let's cut the chase. It says car P with the mass M is initially traveling eastwards when it collides with another car Q of mass of 1.7 meters, which is traveling westwards at 15 meters per second. Ignore the rotation effect of the wheels and friction. The graph below shows how the velocity of car P changes with time. Take initial motion of car P as positive. So, guys, since they've chosen for us that the initial motion of car P is positive, so we know when we talk about the east direction is positive, and the west direction is going to be what? Negative. It's very important. Another thing that you need to note here in car P, we are not given the mass in kilograms is just m, mass m, so which is unknown. It's very important to note that. Now let's look at the graph. In this graph, car P, if you look at the motion there, it was moving at 10 meters per second, right? For how long? For that time. For that time, and the velocity decrease when it collides with car Q. It decreased to -5, which is in the opposite direction, and it moves for that time at a constant velocity. So here there's a decrease, or there is a change in velocity there. So the velocity decreases to 0 and then increases in the negative direction to 5. That's very important. So this graph, it only shows the motion of one object, which is car Q. Now let's answer the questions. Question number 1, it says define the term impulse. Guys, it's very important to define everything according to an exam guideline. An impulse, when we talk about the impulse, we're talking about the product of resultant force or net force acting on an object, and the time the resultant force or the net force acting on an object. Guys, strictly exam guideline when it comes to that. 3.2, it says calculate the velocity of car Q after the collision. So guys, we have the initial velocity of car P and the final velocity of car P, but what we do not know is the velocities of the final velocity. We have the initial velocity. This is the initial velocity of what? This is the initial velocity of car Q. Now what do we want in this question? We want the final velocity of car Q. So if we have three velocities and we're looking for one, we're going to use the conservation of momentum. This is a closed system. So we'll say the total momentum before is equivalent to the total momentum after. So this is going to be the momentum of car P, the mass of car P times by the initial velocity of car P, and then the mass of car Q multiplied by the initial velocity of car P. And then after collision, they rebound, they move away from each other. So they're going to have separate momentum. So it's a mass of car P times by the final velocity of car P, and the mass of car Q multiplied by the final velocity. This is what we want there. So now let's substitute the mass of car M of car P. It's what? It's M. And then its initial velocity there from the graph is 10. It's positive 10. It's going in the positive direction. And then the mass of car Q, it's 1.7, and the initial velocity there, it's -15. How do we get to the -15? Because it was moving, it collides with another car of mass of 1.7 traveling westwards, which is 15 meters per second, so it's going to be negative. And then the mass of car P, it's M times by the final velocity. The final velocity there, it's -5. It's -5, which is traveling at the westwards. And then the mass of car Q, it's 1.7. It's 1.7 m here, guys. 1.7 m. Let me fix that. Let me fix that. It's 1.7 m. Let me get an eraser to erase that. Okay, it's 1.7 m times by what? -15 there. So here it's 1.7 m multiplied by VF. So when we do the math here, we're going to have 10 m minus, when we punch in the calculator, the 1.7 times 15 is going to be -25.5 m, equal to, this one is going to be -5 m plus 1.7 m f, final velocity. So here, the answer here, it's going to be -15.5 m plus 5 m is equal to 1.7 m VF. And then the answer here, it's going to be -10.5 m divided by 1.7. So we'll divide by 1.7 m both sides there. It's a positive 1 point. Okay. When we punch that in the calculator, it will be the V final. It's going to be 6, negative 6,18 meter per second, which is the final velocity there. It's 6,18 meter per second. In which direction? In the westerly direction. Right? Let's go to the following question. The following question, it says, it is observed that the kinetic energy decreased by 175,000 joules after collision. So if the kinetic energy has decreased, that means the velocity has what? Has decreased. So the question here is asking, is the collision elastic or inelastic? So since there's a decrease in the kinetic energy there, it simply means that the kinetic energy, it's inelastic. So the answer there, it's inelastic, because there's a change in velocity, there's a change in kinetic energy. That means the total kinetic energy before is not equal to the total kinetic energy after. Right? So the answer there, it's inelastic. So 3.3.2, it says calculate the mass m. Now we have to calculate the mass m. So in order to calculate the mass m, we have to utilize the kinetic energy that we are given there. So guys, it's very important here. 3.3.2. So the total kinetic energy before is equal to the total kinetic energy after, plus the energy that it has what? The energy lost. Before, the kinetic energy, there was a kinetic energy, but there's an energy that it has lost. So that energy that it has lost, you have to add it in the final total kinetic energy. Alternatively, what you can do here, you can say the total kinetic energy before minus the energy lost, energy lost equal to the kinetic energy after. So you can use any that will help us to calculate the mass, the mass of what is the question? The mass, it says calculate the mass m. So I will use the first one. I'll say the total kinetic energy before is equal to the total kinetic energy after plus energy lost. So the total kinetic energy before, so we'll have the kinetic energy of car P multiplied by the initial velocity of the car P square, and the kinetic energy of car Q multiplied by the initial velocity square of car Q. And then this side the same, but it's going to be the final velocity now. So final velocity plus that energy. So plus energy what? Lost. It's very important to say it's an energy lost. So now the mass of P, it's still what? It's still m. And then the initial velocity of P, it was 10, if I'm still correct. Yeah, it's 10 and 5 and square plus half. And then the mass of P, it's 1.7 m. And then the initial velocity of the car Q, it was negative 15. It was going in the westerly direction. And then the mass of P, it's m. And then the final velocity, it was negative 5. It was negative 5 and square plus the mass of Q, it's 1.7 m. And then let me put this here. It's 1.7 m, and its velocity, the final velocity, is the one that we just calculated. It's negative 6.18 square plus the energy. We're told the energy that it has decreased, it's 175. So it's 175,000. So now it's going to be the math now. So the math here, this is 100 and times half, so it's going to be 50m and plus, and then when you punch that entire thing in the calculator, if you say half multiplied by 1,7 times by 15 square, so this is going to be 191,25, and then the answer from that side. So 5 square, it's 25. 25 times half, it's 12,5 m. And then this side, it's going to be half times 1.7 times 6,18 square. So the answer there, it's going to be, it's positive 32,463 plus 175,000. So, and there's an m here that I forgot. So these two, it's going to be 50 plus 191.25, so it's 241,25 m. And then we take, and there's an m here, So these two, it's going to be 12,5 plus 32,463. It's 44,963 m plus 175,000. So when we take this to this side, it's going to be 241,25 m minus 44,963 equal to 175,000 there, and then we there's an m there, so 241,25 minus 44,963. So the answer here is going to be 196.28,287 m, and then there's 175,000 there. It's 196,287. We divide by 196,287. So your m there. So if we say 175,000 divide by 196,287. So the mass there, it's 891,55 kilojoules. That's the m. That's the mass m there. That's the mass m. So having that, that's the mass that we have there. We are done with that question. Let's look at the last question. The last question, it says use the graph to calculate the magnitude of net force exerted on car P during the collision. Remember one thing, when car P is colliding with car Q, they exert a net force on each other, which is they exert an equal force on each other, which is an applied force, and then that applied force become a net force. So when we talk about the net force, we're talking about an applied force here, because the only force that is acting on them, it's that applied force when they exert on each other. So you can use car P to calculate that, you can use car Q to calculate that. Okay, which formula are we going to use? Are we going to use the impulse formula? So which is F net is equal to, we're going to use the Newton's second law in terms of momentum. So now we're going to do the change in momentum. Change in momentum, it's V initial and V that, and then we're going to have T final minus T initial. Now let's look at, we're going to use the mass of car P. The mass of car P, remember, it's 1m, it's going to be that, so it's going to be 891,55, and then the V final, it's -5 taken from the graph, minus 10 from the graph as well, and then the contact time of car P and Q, it's this is T initial and this is what, T final. So if you're looking at here, so this time the T initial, it's a half of the first box, and this there. So now looking at this from these boxes, they give us 1. Okay, so this simply means that from here, from 1 to 2, what is the unit there? So in order to get the unit there, you say 2 minus 1, which is going to give you 1, and then you divide by what? How many boxes are there? 1, 2, 3, 4. So that means you divide by 4, so the answer is going to be 0.25. So the 0.25 represent each and every box. So that means here it's 1.25, and here it's going to be 1.5, and here it's going to be 1.75. So the T final here it's 1.5, and here in the half of that, here it's in the half of that. So the half, so if you say 1, now we want to know what is this one now. So we'll say 1.25 minus 1, it's going to be 0.25, and we divide it by 2. So the 0.25, when you divide it by 2, 0.25 divided by 2, it's 0.125. 0.125. So this means that now the point that we're going to use is 1.5, and here it's going to be 1.125, right? Those are the points that we're going to use there. I hope that makes sense. So we're going to say the T final, it's 1.5 minus 1.125, and then we punch that everything in the calculator. So it's 891.55, open bracket, -5 minus 10, and then the T final, the change in T, it's 1.5 minus 1.125. So the answer that I get there, it's 35,662 newtons. So the answer there, it's 35,662 newtons. So that's the force. That's the force that is exerted on P during collision. It comes from the westerly direction. I hope that makes sense, guys. I hope that makes sense, and you enjoyed the video.